Thank you all so much for joining the second edition of the Reflect and Connect series. My name is Deanna Kalala. I am a reformed attorney turned stay-at-home mom and proudly serving on the community committee since the summer. And part of what we're trying to do now and going forward is to really give you information directly from the researchers so that you have insights into what they're studying and information for questions to ask and things to consider for yourself or your loved one. This is our second edition of this, so I think we've worked out many of the quirks, but bear with us if we have any. In particular, I would point you guys to the bottom of your screen. You'll see a chat and a Q&A. Feel free to use the chat feature to share any thoughts or reflections that you have and put your questions in the Q&A. It makes it much easier for me to share your questions with Dr. Paul as we go along. And just so you know what the structure of this call will be, Dr. Paul will be providing a short presentation on our topic, which is a reflection on the research that's happening between agenesis of corpus callosum and autism and how that research informs and assists one another. And then we'll have time for a Q&A afterwards. So if you put those questions in the Q&A, I will ask as many of the questions as I can in the time that we have remaining after Dr. Paul's presentation. I gave an introduction of Dr. Paul on our very first call, so what you hear now may sound a little familiar. But yes, but shorter. So here is a very brief introduction of Dr. Paul. Dr. Paul is a California licensed clinical psychologist since 2000, and she received her PhD in clinical psychology from Fuller Graduate School of Psychology and completed a postdoctoral fellowship in clinical neuropsychology from the Department of Neurology at UCLA. Her research is broadly focused on understanding the role that cortical connectivity plays in development of higher order social cognition and the brain's capacity for reorganization during development. She has ongoing neuroimaging and behavioral studies with several unique populations, notably people with congenital malformations of the corpus callosum and adults with autism spectrum disorder, all of which makes her the perfect panelist to talk on this discussion today. And I'll point out, if you've ever come to anything for NODCC, you've seen Dr. Paul because she's been a pioneer in this field since the very beginning of it. So we're so thankful for her time today. So without further ado, Dr. Paul, I will turn it over to you. Thank you so much.
And even this is so me, even at the last minute, I'm like, oh, I want to add that slide. Sorry. So it's funny to me. I was really thinking that this would be so much easier to prepare than last week because this is research and this is what I do all the time. It was so much harder because there's so much in my head and so many things I want to share. So bear with me. I will do my best to make this comprehensible. Let's see. And I have multiple goals here. So I want to give you an idea of what we're doing broadly in research. Families always ask what's going on in research or what's the newest discovery. And one of the things that I've realized is, while you have several researchers that are very involved, myself included, who have been involved from the very beginning of NODCC and are very invested in the community, particularly Warren Brown and Elliot Shearer and I, and now Linda Richards and Fernanda Tovar-Mull and others. We're not always very good at communicating what our process is and what's involved in doing research. And so part of what I want to do is give you a better understanding of what we're doing and how this field has evolved over the last 20 years from my perspective, and kind of where we're going from here. So my work has focused on behavioral issues. And so the issue of psychiatric disorders and behavioral syndromes has been my focus. And some of this will look a little familiar from last week. I tried not to repeat too much. As many of you will know, I am focused on, out of the way. I am focused on looking at how malformations of corpus callosum, dysgenesis, particularly agenesis, so a complete absence, impact behavioral outcomes. How does the absence of the corpus callosum contribute to behavior? And what does the corpus callosum itself contribute to behavioral functioning? So working with Warren Brown, picture over here, who was my graduate school advisor and is now my colleague, we have been trying to figure this puzzle out for quite a while. And as many of you know, our work is focused on people with complete absence of the corpus callosum and no other major brain malformations. Looks like everything else in the brain is working, IQs within normal range, so that we can isolate what is going on because of corpus callosum, with the presumption that if you have other things going on, those will, the impact of the corpus callosum absence will be there as well. So this has been the focus of our work. And out of this, we've come up with what we believe is the primary, the syndrome for primary ACC. And I'm going to switch back and forth between ACC and DCC here. By DCC, I mean dysgenesis of the corpus callosum. But a lot of this work was really focused on agenesis. So not including hyperplasia or partial or more complicated syndromes. So this is the ACC syndrome, which also applies to people with the broader scope of DCC. Does that make sense? So the core syndrome, for those of you who haven't heard me say it before, when your corpus callosum is missing, even though you're able to get information from one side of the brain, one hemisphere to the other, it's not as effective or as fast as it would be if you had a corpus callosum. So interhemispheric transfer, that's what we call that, is somewhat limited. Broadly, that slows processing speed. So everything takes longer if you are missing a corpus callosum. Just thinking takes longer. And it may not be very obvious. It may be more obvious under certain stresses. But slowed processing speed is definitely an important symptom when we start talking about what look like our psychiatric or behavioral syndromes. And then poor processing or difficulty with complex new tasks. So those are what we think are the core symptoms. And then out of that, that impacts all sorts of other areas of functioning, like verbal skills or your ability to read social cues, coping with daily life. So these secondary deficits that I've listed here are just a handful of things that Dr. Brown and I specifically have studied and have research to support. And I grouped down here symptoms that actually match with the behavioral diagnosis of autism spectrum disorder. So difficulty with reciprocal communication, reading other people's intentions, recognizing emotions in verbal processes, inferring other people's mental states. All of those are symptoms that are common in autism spectrum disorder. And as we'll talk about in a little bit, there appears to be a portion of the group of people with ACC that really fit that diagnosis behaviorally. There are also some symptoms that come up that overlap with other developmental diagnoses. So if you have difficulty spontaneously retrieving memories, so without a cue, without somebody reminding you, but just to pull something up quickly, that might actually look like you weren't paying attention and you missed it in the first place. People may make that assumption, especially for children in school. If they can't get the information and they just were there and they just heard it, well, you weren't paying attention. Maybe they were paying attention, they just can't cognitively get to that. So that would look like and may be interpreted as an attentional problem, when it may not be. It may be a slowed processing speed problem. Another way slowed processing speed can look like an attention problem is if you are listening to me talk and you hear my first couple sentences and then you're trying to make sense of what I just said and you miss the next few sentences and then you pick it back up. Well, you're kind of not paying attention, but it's really that you're just taking more time to process than I'm giving you. Does that make, I hope that's clear. So what we believe is, and what we've seen so far is that the symptoms that look like attention problems are clearly associated or very closely connected to the slowed processing speed, not to attention itself. Another symptom that often comes up as part of the attention deficit profile is some difficulty with cognitive control, so impulse control, difficulty inhibiting yourself, poor flexibility in response to change. And those symptoms, again, can be due to being overwhelmed, getting behind on what's happening, the processing of complexity, and then maybe becoming rigid in your daily life, a little bit inflexible because you've got to have routines in order to cope. So those behaviors, the rigidity, the cognitive inhibition problems, again, can be attributed to ADHD or fit into that profile, but may actually be secondary to these primary ACC symptoms. And before we go any further, since I am talking about these, I want to step back and repeat something that I said last week. I want you to be really clear that we're talking about agenesis or dysgenesis of the corpus callosum, which is an anatomic condition. It's a concrete, we can see it. The only way to diagnose is by brain scan. All of these developmental disorders that ADHD, autism, the psychiatric disorders, anxiety, depression, those are behaviors. They're clusters of behaviors that tend to cluster together. We think they probably come from a similar cause or similar causes, but they're not based on the anatomy. So if an individual demonstrates this symptom configuration, this cluster of symptoms in their behavior, they can meet criteria for this behavioral syndrome regardless of what might be causing it. I'll say that again. So if an individual meets criteria for an autism syndrome based on their behavior, it doesn't matter if they have ACC. ACC may be part of the cause, it may not be. That's a scientific question. That's not a clinical question. The value of these clinical diagnoses, these psychiatric diagnoses, is that it's a way of communicating between professionals about what symptoms there are. It helps us understand what symptoms are likely to be associated, what the trajectory of that condition is, potential interventions. And none of these behavioral syndromes are as specific or as encapsulated as ACC. It's not as, there are many causes for autism, there are many causes for ADHD. So to say it's ADHD behaviors secondary to ACC, well, okay, maybe it is. So we're kind of talking about two different things. On the other hand, the behavioral symptoms are very real and are very important. And it's, as I will say in a minute, the association between behavioral syndromes and the brain anatomy of the corpus callosum is really important for research. So in addition to these secondary deficits that I've got listed here, I think there are other cognitive challenges that emerge, especially as people get older. Social isolation becomes more of a problem. generalized anxiety because coping with things is difficult. Social anxiety is an issue because social conflict comes up. Depression, difficulty sustaining employment. So all of these behavioral challenges that can become psychiatric diagnoses, conditions to be treated, may also emerge in part because of the cognitive challenges from DCC. So we saw that from our previous work, Dr. Brown and I, that there was some overlap with autism symptoms. So this is an example of how we've progressed in research and how we've been able to accomplish what we have accomplished. I'm transitioned. I still work with Dr. Brown. I'll talk about this in a second, but I also work at Caltech in a lab here. And at Caltech, we study autism. And we brought in a collaborator, Dr. Christina Corsello, and she is an expert in autism diagnosis. She has worked very closely with Kathy Lord. If you know anything about the ADOS and the gold standard of autism diagnosis, she's a trainer. She worked with us. She has reviewed all of the videos of our agenesis patients and a bunch of our autism participants. And by bringing in her expertise, we could really do an in-depth dive to say, are the adults with ACC, do they meet criteria for autism? Do their behaviors really look like autism? Or are they just sort of like it? And what I want you to grab from this slide is that we had, in the autism, this is the diagnostic criteria. So 2 different scales on the diagnosis instrument that we use. And above, or 2 and above says this is a spectrum. They're on the autism spectrum. They meet that criteria. So we have these individuals with agenesis in blue who clearly meet on both the social and communication symptoms. And they're in that range. What's interesting is the individuals with agenesis who don't meet the autism symptoms on both scales, there are a couple that meet on one scale but not the other. So, this person met on social, but they must not have met on communication because they didn't get the diagnosis. But most of them clearly did not meet criteria on either. And this group in green are adults with autism that are matched on intelligence. And so this is what we see in an adult autism population, this group as far as their scores. And you'll see our ACC with autism kind of looks similar. The point here is that we found in the adults that about 30% met criteria for an autism diagnosis based on their current behavior. And that those who didn't meet criteria, most of them really didn't show those symptoms. So it seemed to be 2 different groups. Now, the other component of diagnosing autism is not just your current social skills, but your behavior throughout development. So these 2 questionnaires, the social communication questionnaire and the ADIR, are looking at childhood behavior. Well, we were studying adults. And so when you study adults and you ask their parents, how were they at 5? Now being in my 50s, I can say, boy, that's a long time ago. I don't know. So we're always a little bit, not totally sure. There's some concern about accuracy in this reporting, but it looks like that in our agenesis or adults that have ASD symptoms, they may, and again, high means they meet criteria for an ASD diagnosis. Some didn't seem to have those symptoms when they were younger. So this is about lifespan, younger years. Did your child meet ASD criteria back as a kid? Only 13% of our group, according to parent report, actually had those symptoms during childhood. which is interesting and fits with our understanding of maybe this being an emergent symptom profile, that the symptoms of ACC, the behavioral symptoms, get worse as you get older, into adolescence, that is. But we can't know unless we actually look at children, young children. So I'm going to wrap up my comments on the behavioral syndrome research. And what I want to show you here is most of what has been done in understanding the behavioral syndrome has been done by Dr. Brown and I. There are a few other labs around the world that have done things, and I don't want to in any way minimize their work. But as far as the larger samples, and we've collaborated with other groups. So I, again, don't want to minimize their work, but we have contributed a lot to this field. This has been our focus. And so at Travis Research Institute for the last 30 years, we have been doing research on this topic. And then in 2004, I moved over to Caltech, which is just down the street, and started working with Ralph Adolphs. I still have a position at Travis Research Institute with Warren. This is in part me, I guess, bragging. I'm just kind of marveling. The work that Dr. Brown and I have done, all of that backed up explaining the syndrome. We had one research grant from the National Institute of Health in 1999 and 2001, and that supported me for a couple of years doing postdoc work. And he has had a few $1,000 grants through the years. The work is done by Fuller graduate students. Fuller graduate students pay to go to graduate school. They don't get paid. They don't get stipends, so they pay a substantial amount. And at Caltech, I've had, you'll see in the years here, a few small foundation grants to help support this research. But at some point I went back just to try to understand like how much money have we had to do this research? And Dr. Brown's position is a faculty position. Mine is all research. So I have to generate the income to support my position. From 2001 to 2018, all of the work we've done was supported by $16,000 a year. And that's whatever could go to my salary, to students, to researchers, to anything, travel, and I guess I just want the families to know that we are really committed to this. We really care. Because we don't make any money to do this, and we have very little funding, and we really wanted to figure out this puzzle. So this is part of why we're doing these research discussions, to help you understand what goes into doing this work and why we need your help. Now, I will say, since then, since 2018, things have changed a little bit because we've shifted to focusing on developmental studies. And I did get a grant, the first grant from the NIH since 2001, to study behaviors in ACC. And that's very exciting. That's NIH is what funds research in medicine and these kind of conditions. So if you want to know what's going on in research, or you want research to get done, that's what's got to happen. It's got to have the funding to do it. Well, since we don't have funding to do research in ACC, I started looking at what's being done in autism in children. So in development, there's a lot of research looking at biomarkers. So what can we look at in younger children that will predict how they're going to do? Can we identify the neural systems that are involved in autism or ADHD so that we might be able to change the outcome of treatment? And how do we understand this whole puzzle of genes and how genes and molecules and the whole developmental process results in behavior? So as I said last week, we have these other fields of neurodevelopmental condition research, genetic disorder research, that are trying to understand the neuroanatomy behind their conditions, those diagnoses. And there are three in particular that the corpus callosum appears to be involved in these diagnoses. Autism, so there's evidence that the corpus callosum is larger at one point during infancy and it's smaller in childhood and adulthood. So something about the development of the callosum may be related to development of autism symptoms. Fragile X, which is a genetic condition, and Down syndrome, again, another genetic condition. Both of them have evidence that in the corpus callosum, the structure is not as well developed and not as robust as in typical kids. So these are populations that are interested in understanding the corpus callosum and its role. So as I was saying, they want to know that in these, and this is the percentage of Down syndrome kids that have autism is about 20%. Kids with Fragile X, autism diagnosis is 25 to 75%. And in agenesis, the estimates are 30 to 45%. Well, if only 1% of the typical population has autism, this is really high. This says these kids with this brain malformation or with these genetic conditions are at very elevated risk of developing autism. And we can't diagnose autism before 18 months. But we can diagnose ACC and Fragile X and Down syndrome before 18 months. So let's study these kids and figure out what is it about them that explains their vulnerability to ASD symptoms. So with that in mind, at Caltech, I've developed the ACC infant study and the child study. And without trying to explain why they're two separate studies, except for the fact that we have funding for the infant study and we have no funding for the child study. The infant study is longitudinal from 6 months to 36 months, and it's parent reports with the option for some people to come in and get direct assessment. The child study is also 6 months to up to 18 years, and it's all remote. And this idea was developed by conferring with Dr. Jed Elison, who was a postdoc with us at Caltech, and also now is a professor at University of Minnesota, and has a lot of experience in autism research, and is a very established collaborator in that field now. So again, like we reached out to Dr. Porcello, with our limited resources, the approach was who is doing research that is looking at the corpus callosum and an associated condition that would be interested in collaborating with us, and we can use their expertise and even more so, maybe collaborate with comparing our groups. So the infant study is trying to understand, and the child study as well, what's the typical developmental progression and the common delays and strengths in children and infants with agenesis of the corpus callosum. And can we identify in the kids that have ACC what aspects of their development may predict the later development of autism symptoms? And does that then help us predict which other kids might develop autism symptoms and how the corpus callosum contributes to that? So by working with Dr. Elison, he was able to help us develop our research battery so that we don't have to collect comparison group data. One of the things that is a challenge in research is we have to collect information from our group of kids that we're studying, kids with ACC, but we have to also collect as many or more kids that are typical and kids, if we want to study other kids with autism or something, we have to collect all of that data too. Well, by collaborating with Dr. Elison and with the Autism Centers of Excellence IBIS program, and with a group in Canada, a few other groups, we're able to collect our infant study protocol and child study protocol on the same tests, and they have the data for comparison. So we don't have to raise that one. So for the infant study and the IBIS group, they have a low likelihood group. So kids with no first degree relative with ASD, no reason to think they would develop ASD. Then you've got these high likelihood kids, two subgroups. So both these groups have a sibling with autism, which puts them at risk of having autism. It's highly associated in families. And some of them do go on and develop autism, so that's the positive group, and some of them don't. And then we have two other groups, Down syndrome and Fragile X, which I showed you earlier, also have a high likelihood of developing autism. So we have these low likelihood group, and the JEDS lab in Minnesota also has a low likelihood group, large samples from the community, and then these groups that are at risk that we can use as our comparisons. And this is just to show you what the infant study, very briefly, contains some of the tests that we're doing. We've been focused on autism type symptoms, so communication skills, emotion skills, but also basic motor development, language development, temperament. And then for some kids between 24 and 30 months where they're actually being assessed in Minnesota, so we can assess for autism and again compare them directly to kids that are at risk for other reasons and that have autism. For the child study, we're in process because our grant started in 2018 and it just ended. We're kind of coming to the very end of it. We are putting in a renewal to extend, to look at children, extend the age range up, and look more at the issues of school readiness, and then development of those other developmental diagnoses. Autism appears typically by age 3, whereas ADHD, learning disabilities, obsessive compulsive disorder, anxiety, depression, those symptoms in children typically develop in school age. So our research battery for the school age children is focused on those issues. And again, we'll compare to these other groups. To just give you a quick overview of kind of some of where we're at, this is not all published yet, so please keep that in mind. We're in process. The infant study has been going on for 5 years. We have over 200 kids enrolled. Most of them are white, but we have other races represented. We have been able to do it around the world because we're doing it remotely. So primarily the US, UK, Australia, and Canada, because it's all in English. And then a few other countries. Our sample still is a little bit more males than females. I'm not sure why. And the ethnic breakdown is here. One of the things that we're trying to do, I'll mention again later, is because we have this research battery that we think is pretty robust, has been used for a few decades now in other conditions, we're sharing it with other countries and researchers of ACC in other countries. So they're using the translated versions of these tests. So hopefully our group will expand. And again, this is preliminary data, but just to give you a hint of some of what we're being able to come up with or discover by doing this comparison across groups. This is the low likelihood group. This is high likelihood that does not develop autism. This is high likelihood, the pink, that does develop autism, and then ACC. And this is language, words produced at 12 months, 18 months, and 24 months. And what you can see here, the stars indicate a significant difference between these groups and ACC. The ACC group, language development, is very similar to the at-risk children who develop autism, and is significantly different at 18 months from the low-risk group and the high-risk group that doesn't develop autism. So at 18 to 24 months, we're seeing an impact of ACC on language that we've never been able to document before. And the same thing is apparent in words understood, that the ACC group is not keeping up with the language comprehension of typical kids. Now, there's evidence from Dr. Elison's group that those markers of language development in the high-risk kids predicts development of autism. With a few more years of longitudinal data, we're going to be able to identify in our ACC kids, do we see the same thing? Does language ability at 18 months predict social skills at 36 months? Or even anxiety at 5 years? That's the goal, is to be able to extrapolate this out further across development and to be able to compare across these different groups. We also have Down syndrome on Fragile X data, which I'm not going to show you, but to see how are these groups similar or different. As I mentioned, one of our understandings from just the work that Dr. Brown and I have done is that in agenesis, the disabilities become more apparent, the challenges become more apparent with age. And we believe part of that is because the corpus callosum, even though all the nerves are there at birth, they continue to myelinate. And around age 8 to 12, right around puberty, there's this increase in myelination of the corpus callosum in typical kids. Well, if you don't have a corpus callosum, there's not going to be that change, because they're not going to see a change in interhemispheric transfer because of myelination. So that's where we tend to see this kind of gap emerge. And that's what we're going to study in the child study, and why we're putting in the grant we're putting in now. Before I wrap up on this, I wanted to comment on what's going on in research and some of the things that I'm really excited about. And one is the International Research Consortium for the Corpus Callosum and Cerebral Connectivity, IRC5. IRC5 emerged out of a collaboration of Dr. Elison and I when he was a postdoc here. He and I set up 10 years ago, a scientific salon, and we brought together researchers who were studying corpus callosum connectivity. And there were 20 of us, and we spent 3 days, and we just talked in depth about what are we studying and why are we studying it, and what are we finding, and how can we collaborate more effectively. And out of that, we were really inspired to start an ongoing collaboration. In 2015, Dr. Linda Richards hosted us in Australia. And then in 2017, we officially formed this group. So 6 years, we've been meeting regularly, and these little stars indicate where our members are from. So we have scientists in all of these places who have joined our group, and they study everything from molecular behavior or molecular development of the corpus callosum, the genetics. Dr. Shearer is a big part of this, the genetics of the corpus callosum development and corpus callosum malformations. Diagnosis, got multiple people in Europe that are experts in prenatal diagnosis and trying to really refine that process so we know that when you get a prenatal diagnosis, it's accurate. And then neuroimaging, adult or children and adults, all the way to behavior. Now, this is a really unusual research consortium because most research groups that study this type of cognitive or neuroscience groups tend to be consortium that have the same area of expertise. So they're big groups that study genetics all around the world. They're all studying the genetics. Our group is strange unusual, not strange or unusual. We're unique because we are not only covering multiple countries and multiple languages, but we are covering a wide range of scientific fields. So it's taken a lot of time and effort to understand what do you mean by that terminology as a prenatal fetal pathologist, and what do I mean by it as a cognitive neuroscientist. But if we're going to understand the best predictors of outcomes in ACC, we need to understand the variations of ACC. Some of it's caused by this type of gene or this type of molecule or this molecular process. Some of it's caused by something else. And we think that's going to inform our understanding of the variations that we see in the ACC community. So we think it's important to cover this whole range of expertise. And we've been meeting every year since 2015. And our goal is to be able to share all of our research data with each other, because there's now, Dr. Brown and I have studied 150 adults. I have 500 or 600 infants and children in the infant and child studies. Dr. Shearer has 800 or more, 1,200 in his work. Dr. Richards has 100. If we can pool all of that data together, we can learn so much more. But to do that, we have to have the mechanisms to do it, to pool the data. We've got to have the computer platforms to do it. We have to have time and research to meet, or resources to meet together. So that's our goal, is to be able to really begin these collaborative work. In the meantime, we've had a small grant from a family foundation that has supported us a little bit to help with meeting as a group over the last 6 years. So each year we have been able to at least meet together and have a website and get started. It's ambitious. It's exciting. It's fun to meet together. And I think it really refines our work and helps us be more available to the families. And I think we'll be able to move a lot more quickly, scientists, if we can get this consortium really off the ground. Because as I've shown, working with experts in other fields is a great way to optimize resources. And we're trying to do that so that we can answer your questions more effectively. So if you have any interest in helping or knowledge about fundraising or any about development of nonprofits or those types of things, we definitely could use your help. A group of scientists with big ambitions can only go so far. We're not business people. But I hope that you will continue to give us feedback, participate in our studies, each of our individual studies, knowing that we are going to share that with each other and that we are all working together. Participate in the infant study, in the child study. And I just want you to know we are committed to giving you the best that we can and using whatever resources we have to help these families. So if you have interest in participating in my work, the infant child studies, or even in Dr. Brown's work, you can find information here at accinfantstudy.com. And thank you for your time.
Wow, thank you so much, Dr. Paul, for walking us through the research. I was over here taking copious notes myself, and I can tell you in the chat, people had lots of thoughts and feedbacks. So much of your research resonated with their experience, and we've got a lot of participants on here who either themselves have ACC and autism or their loved one does. So these are folks that are really thankful and appreciative to get this information. So we do have some questions, and one of the first comes from a mom who asked for clarification about the behaviors of ACC and whether they get worse as an adult versus a child. And I know you talked about that a little bit later with respect to myelination. Can you just explain what
Yeah.
myelination is a little bit more?
Thank you. Yeah. So the nerves that make the corpus callosum are these long axons, and they have an insulating cover that we call myelin that allows them to work more efficiently. Like if you insulate an electrical wire, the information or the electricity moves more effectively. That's the way our axons, our neurons work. And at that point in development, those axons get more insulated and they are more effective. That's if you have a corpus callosum. If you don't have a corpus callosum, that's not going to have an impact. As to development, my understanding through studies and through observations is that what we typically see is there are some kids that lag behind early on, from infancy on. There are a lot of kids with ACC or dysgenesis who progress pretty well and keep up with their milestones until about 6 or 7 or 8 years old, and then start to see some challenges. And we believe that's because the other kids are starting to rely more on the corpus callosum and that connectivity that these kids don't have. So around early elementary, we see challenges emerge. Some kids with ACC still hang in there and kind of keep up until closer to junior high or high school. And then you start to see difficulties with social skills or other challenges. By adolescence, most of the people that I know of with ACC are struggling in some manner. And it may not be that they're dramatically behind. They may not look profoundly autistic. Like we saw, a bunch of them don't meet that criteria, but they do struggle some. So you'll have those that have already met criteria and look like they have autism or some kind of behavioral problem, and then those that have challenges. And what we see into adulthood is not that it gets worse, because individuals with ACC can learn and they continue to learn. They just don't learn the same way we do, or that most of us do. And part of that is because of inference. We watch other people and figure out, oh, that person's getting teased. I don't want to get teased that way. That happened to me. I'm going to change my behavior. People with ACC seem to have a harder time learning that way. And so they need a lot more rehearsal, a lot more repetition, a lot more practice, a lot more concrete examples of something to believe that it's a pattern. And so it takes longer to learn those skills. They learn it more by rote, not by intuition. So Dr. Brown and I often tell parents, your expectation for growing into adulthood needs to be extended closer to 30 instead of 20.
Okay.
That it's, if you have to learn it all by patterns and repetition and learn it cognitively, then it's just going to take longer. You can support that by using systems and trying to use automate life as much as possible, so that the things that are new and complicated get the attention and they don't spend a lot of time, mental energy on things that they don't need to spend energy on.
That is a very helpful explanation. And thank you for road mapping, because we've got lots of parents here who have young children. So that helps, I think, to have people know those critical juncture points to look out for. Another person, a parent that has an 18-year-old with ACC, asked, I found that the therapies and consequences in ACC and ASD is pretty much the same. All the strategies to work with ACC kids are almost the same as that in ASD kids. So why is it important to make that differentiation? Funding for research, placement at schools. For us parents, why is it that differentiation is important if therapies and strategies and consequences are pretty much the same? And while she's answering this, guys, feel free to put more questions in the Q&A. I'll ask them of my own if none come up, but feel free to add them there.
Well, there are multiple reasons. One is not everybody with ACC ends up with autism symptoms, right? So there's something unique about those that do and those that don't. And we want to be able to predict so that we can help the kids that are at risk, really at risk of autism. And when I'm differentiating, it's not that I'm distinguishing between ACC and autism, it's that there's all of our kiddos that you're here for have ACC. It's what is it about some of them that look like they have autism symptoms? And even though so far it looks like perhaps the autism treatments work, we don't have, that's only anecdotal. So we don't have any systematic studies of interventions in agenesis of the corpus callosum. We can't say that in all of the, there are 400 kids that have agenesis of the corpus callosum and autism symptoms, that these interventions work in 50% of them, or 80% of them, or 10%, or we have no idea. We know it apparently works for your child. But will it work for others? We don't know. And that's why we do this kind of behavioral research, so that we can predict and then use the best strategies.
Another question that I have is, we're also thankful for the research that you're doing right now. Can you talk a little bit about how this research will contribute to improving the quality of life or outcomes for individuals with ACC and co-occurring ASD?
Yeah, I think one of the things is, by us tackling this question, we're clarifying, we're trying to raise awareness of ACC and challenging the people that say, oh, well, if you have ACC, you can't have ASD. So we want to get rid of that, because that's a way to avoid doing interventions for kids. So we want to clarify that. One of the most profound things that we can do for any child with ASD or any neurodevelopmental disorder is intervene early. And if we know the strategies to intervene early and we know the targets, then we can, like I was saying, if language is a problem, we intervene on language. So our goal is to figure out, what are those markers? What are the behaviors that are making a kid with ACC particularly vulnerable to autism? And then from that, develop interventions that we can start implementing in other kids at younger ages. The other thing is, a lot of our adults with ACC, on their best days and in their best moments, function remarkably well, but then have times when things are really difficult. And so getting assistance and getting special services and therapies can be difficult if we don't have research that backs up and says, yes, this person at their best can perform well, but we have solid evidence that their brain abnormality contributes to these weaknesses and these vulnerabilities. And so with that, then I can put out reports and we can hopefully get more services even on into adulthood. And it also helps set expectations. One of the things that I've seen that's really made a difference is, if you know that this is something as a challenge for you and you know why, then you're more accepting of yourself and you can make choices to adapt and compensate and get the help you need. But if we don't know what the problem is, often we tend to try to minimize it and ignore it, and then it just gets worse and we make a bigger mess. So that's been part of my hope. We're not going to fix ACC, but if we can help parents and children have more realistic expectations and better strategies for compensating, then things, those secondary, the social isolation, the anxiety, we can avoid some of those other symptoms.
Mhm. We have another question from someone. She thought it might be irrelevant, but I think it's very appropriate to ask a researcher, especially on this type of topic. But she asked, can ACC/ADHD and autism be characterized as having some form of brain or white matter deficiency, with CACC itself being a form of very large white matter deficiency?
Yes, and that's so it is a white matter malformation, and that's why our research consortium covers corpus callosum and other types of cerebral connectivity. That's all those white matter conditions. One of the things that we're curious about is that there are people with ACC who have more global white matter loss and some that don't. It seems to be isolated the corpus callosum. And that's probably related to the genes or the molecular processes involved. But I'm curious, could that help us predict behaviors? You know, is that difference in the degree of white matter involvement one of the differential factors in outcomes? But again, until we can merge all this data together, we're not going to know. And so just before we have to wrap up, and I know you're going to go, I wanted to let you know, as far as what we're doing to fund this work and to keep it going, I know Dr. Scher has had research funding because he's doing genetic work, and it's easier to fund genetic work. We've had a hard time getting behavioral work funded. And so advocating and talking to your Congress people and talking to anybody you know that is in government, that to make them aware that this is a problem and it needs to be funded is really important. And we put in grants repeatedly. Funding rates for this kind of thing are about 12%. So you have a 12% chance of getting the funding that you apply for. It takes about a month of your time to write the grant. And I was just looking back and realized for the grants that I've gotten, it takes about 2 years from first submission to actually getting money. So it's just not to excuse the fact that we don't have more answers, but to explain, kind of like with our kiddos, to explain why this takes so long. It is a really drawn out process. And so we have a grant that we put in to do all this data merging, and we got our feedback, and we can resubmit in March, and we will resubmit in March. So just to let you know, we're continuing to work toward that. That really is our goal.
And I'm sure everyone that is on this call would be interested in how they can help further this research. So Barbara, if you can you put in the chat the links for IRC5's website and also the link for the volunteer page for NODCC. We are both organizations actively working on how to improve advocacy, how to improve funding. And so we could really use your support if any of you are willing and able. And while Barb is probably frantically looking to put up those links, we did have, if we can sneak in one more question, is that okay?
Sure. Yeah.
Okay, we got one more question. This will be the last one. The person asked, is medication the same for ACC with ADHD and autism symptoms? I've heard anecdotally that medicines don't work for ACCers even when symptoms are the same.
So one thing I did not say that is important to distinguish is I think a lot of times the ADHD and autism, or the ADHD symptoms may not be true ADHD. They're they're secondary to the ACC, in which case the medications may not have the same effect. But there are certainly people with ACC who have true ADHD, like the brain systems that are typically involved in ADHD are functioning atypically. And so those individuals, yes, the medications may work well. And all of that, I mean, unfortunately, in psychiatry, we're still at a point where a lot of it is trial and error. The genetic testing and things are getting better, but with a child with ACC, my typical advice is start slow on any medication, psychotropic medication. Try it out, see if it works, and then make a decision for your own child. But you do have another variable in the mix that other kids don't have. So you can't presume that your child's going to respond the way a typical kid is.
Well, thank you so much, Dr. Paul, for your time today. This was really a phenomenal conversation. I know I learned so much from watching, so I hope everyone, and while folks are on, feel free to DM other panelists. I saw some comments going back and forth like, oh, I have that too, or I know that also. So feel free to reach out. That's what we all are here for. Just a couple of quick announcements that this month we also have coming up a mother's conversation and a father's conversation. The mother's is on October 24th and the father's is on October 28th. And these conversations are really to extend the talks that we're having with researchers, because you are also experts on your condition or your loved one's conditions. And these are opportunities for us to get together and talk about the experiences that you have had and the things that you've tried or the things that you've learned. I think in the chat, someone mentioned, I wrote it down somewhere, but like a different type of gestalt communication, which is something I had never heard of. So lots of learning that can happen between one another. So I encourage you all to come out to those calls. If you have any thoughts or comments about this particular format or the timing or anything, we'd love to hear your feedback. And then the last plug is that we'll have more of these calls. Actually, we're so fortunate that we have this great relationship with IRC5. And so we'll be rolling out a number of topics over the next few months. And there'll be hopefully about 1 to 2 calls a month where we're talking about different topics that will be relevant to you or your loved one with ACC. So we're so thankful to IRC5 for this connection and for sharing the research and information that you have with all of us. So with that, I will just say thank you, thank you, thank you. And I hope you all enjoyed this presentation.
Thank you, Diona. And thank you to all of you who participate, because your information and your expertise in your kids is priceless. So I really appreciate it.
Absolutely. All right. Y'all have a great day. Thank you.